So the first part of lecture 12 I know was a bit dense and perhaps a bit difficult to get through, but this one, lecture 12 part 2, surface water, we're going to run through fairly quickly. It's going to be nice and smooth, just some new vocabulary terms. We're going to retouch on some concepts that we've talked about earlier with weathering and erosion. Firstly, I want you to think back to your 6th grade science class and remember that diagram of the water cycle. You've got your precipitation, your runoff, maybe it included runoff, but then condensation and evaporation, and then precipitation, so on and so forth. There's a few more pieces and parts that we'll add to it today, but the big thing about this is that people may think about it in terms of, well, this is just how water moves around, but it really is the recycling of water. So there's not new water, it's just water going from one place or one form to another. Runoff is something that we've talked about quite a bit before. It's really just precipitation going from a high, topographically high, to a topographic low, where it'll eventually settle into that topographic low, forming a lake or a river, or infiltrating into the groundwater system. If you're thinking about the relation of this to, or the water cycle on whole, or hydrologic cycle on whole, to the last lecture that we talked about, you might be wondering, well, how is water a limited resource if eventually the oceans evaporate, turn into clouds, and then they precipitate down as fresh water, and then that infiltrates into the groundwater? And yes, that does happen, and yes, that is a natural process of desalination, but this process happens an awful lot slower and in much lower volumes of water than what we pump out and use and contaminate or discharge eventually to the ocean. Remember Finding Nemo, all drains lead to the ocean eventually. So in that regard, water is a limited resource, or groundwater is a limited resource, especially the kind that we can drink. So this is just another animation, a reminder that it's from the highs to the lows, and mostly in the past we've concentrated on that becoming rivers and then moving around and eroding rock, or weathering and eroding rock and sediment, but part of it will infiltrate and go down into the groundwater, and that's yet another connection between surface water and groundwater systems. So we looked at these proportions in the first part of the lecture, but remember I said that we could break it up further into what parts of the surface water are in what. So if we look at lakes and reservoirs, so lakes and ponds, we're at less than 0.5%. And then soil moisture is second in charge. That actually has about 0.2 or closer to 0.3%. Water vapor in the atmosphere, and then river water is actually all the way at the bottom, which might seem kind of counterintuitive, be it that here in Michigan we can't really spit without hitting water, as my grandpa likes to say, and usually that's either a lake or a river or stream. But for the earth on whole, that's going to be 0.004%. And that's just of the total volume of fresh water. And again, we've talked about runoff before, but to put it in the specific context of surface water and groundwater connections, runoff is either the natural runoff from the high to the low because of some slope and the degree of vegetation and a couple other factors that we've already discussed, or in urban settings where we've specifically diverged the flow of water to go around buildings and go into drains and work with our constructed life. So in these settings where we have our storm drains and stuff, usually on the edges of parking lots or roads, that means that when we have a storm event, it's going to pick up everything that's on the road. So that could be trash, it can be oil, gasoline, other contaminants of concern. It's going to pick up anything that's on the pavement, transmission fluid, a lot of vehicle stuff, because fixing your leaking vehicle can be expensive, but anything that's left on the ground that can be washed away. One thing that can be problematic that's pretty common is from launders. A lot of the constituents of like high strength detergents and stain removers can be groundwater contamination. So if that spills out or it wasn't properly disposed of, then the runoff can carry that to the drains, and eventually these drains will lead to some surface water body, whether it goes through a wastewater treatment facility first or not. And then those surface water bodies at some point connect with the groundwater at those edges. And so either that or they'll drain out into the ocean, and then that becomes quite diluted from there, but the main concern is with its direct connection to the groundwater. Reminder of those factors that affect runoff is number one, the vegetation, and this is for specifically a natural setting. So the more vegetated it is, the more plants there are to absorb the water, which means there's going to be less runoff because those plants are going to absorb some of the water. The rate of precipitation, of course, if it's raining really hard, you're going to have more runoff than if it's just a light sprinkling. Soil composition, if it's a really absorbent soil, it's like a dry clay, it's going to absorb more water. If it's something like pea gravel, then you're going to have a lot more runoff. Or if it's cement or blacktop, that's not very porous, you're going to have a lot of runoff from that. And then, of course, the slope. The steeper the slope, the more runoff you'll get. The other component of vegetation and how that interacts with runoff is that, number one, yes, the more vegetation there is, the more the water it absorbs. But the more vegetation there is, the more tree branches, the more leaves. Really what they're doing is they're providing a pause in between the water droplets falling from the sky and hitting the ground. So it'll hit the leaves and the bushes and the branches and then run down the sides of the leaves or drip off the leaves. And so it's going from the velocity that was moving through just the atmosphere to now the velocity that it's just dripping off of the leaf that's not that high off of the ground, which means that it's going to have a lesser impact onto the ground. Generally, the stronger the impact, the more runoff we'll have. Also, if precipitation is just falling onto barren land, then it's that direct velocity, that force of gravity, just 9.8 meters per second squared towards the ground. And then this can form a lot of clumping in the soils, especially if it's clay rich, which then we'll get a bunch of aggregates, which decreases pore space, and the less pore space there is, the more runoff there will be because there's less space for that water to infiltrate and occupy. It's going to run off the surface and move somewhere else. With the rate of precipitation, what's really driving that is not necessarily the speed that the water is falling at, because it's all falling at the speed of gravity, 9.8 meters per second squared, but rather the quantity of water. So if you're having a light precipitation, that means that there's less to be absorbed, so the pore spaces aren't as filled, which means that it's going to be absorbed rather than run off. But if you're having more droplets, then all of those pore spaces will become filled. It takes longer for it to infiltrate deeper and for those pore spaces to open back up. So if those spaces are already occupied by fluid, then any additional fluid or water is going to flow off the surface, adding to the total runoff. And there's not too many tricks or secrets with slope. It really is just the steeper the slope, the more runoff, because there's more of an angle there. But the greater the slope, also there's greater potential for erosion. So the more water is going down that slope, the more rocks it'll pick up. You might have some mass erosion or mud flows or rock falls, things like that. Now into the nitty-gritty with stream systems. This is, again, something that we've touched on. So when we have runoff, it eventually goes to a low-lying point, which is streams or rivers or lakes. And then as the amount of runoff increases, the channels, the streams, they become wider, they deepen, they become larger. They facilitate, or the capacity of those water bodies becomes greater as there's more water coming in. With streams specifically, because they're not nearly as large of a quantity of water as rivers, they dry up much more frequently in long stints without rain, but they quickly fill back up because that is the low-lying point. That's where the runoff is going to head to. If there's a more steady supply of water or runoff precipitation, then eventually A permanent waterway will develop, it becomes larger, and eventually we have a river that will not so easily dry up when there's a long stint without rain. Watersheds and divides are probably something that you guys have also heard about before. For me, I thought that watersheds and aquifers were the same thing all the way up until going to college and taking my first geology class. And they're definitely not the same thing. They're two completely different things in that an aquifer is below the surface and a watershed is really only talking about the surface, although it is a two-dimensional feature in that it's an area. A watershed is any area of land where all of the water is flowing into one common point. So really this usually surrounds a major river of sorts. They can be small, they can be large, it just kind of depends on the topography of the land. And a divide is some natural feature that separates those watersheds. And mind you, because the center point of these watersheds, or what defines these watersheds, is all of the runoff or streams flowing into one major low-lying point, river, or larger stream, that these divides are some kind of topographic high that separates these. It's going to be the line on the highest point of the topography of the area where part of the water that hits it, or the precipitation that hits it, will flow west or east or just opposite directions, period. Most people think of flooding as just having water where you don't really want water, which in a lot of sense, or in common sense, it is, but this term is actually specifically when these low-lying points or accumulation points, like streams or rivers, are overflown, meaning that they specifically, the crest of the stream, so this very surface of the stream, reaches a height where it's exceeding the bank, the river bank or the stream bank, which is evidenced erosionally as to the normal fluctuation level of the water. So anytime that the water exceeds that level, it's considered a flood. And that flood can be just a little bit above that bank height, a couple inches, or it could be several feet, something more significant where probably people's homes are being flooded if they're close enough. But either way, still meets the criteria for flood. Upstream floods are when it rains so much in such a short period of time that the stream or river can't actually drain downstream. The water can't move downstream at the same rate that it would need to in order for that water to not flood up. So it only has a certain capacity, and that's exceeding its normal capacity, which means that everything upstream is actually going to flood. On the opposite end, you can get downstream floods, which is kind of like a normal flood or a regional flood where you have a lot of water over a longer period of time where just the whole area is increasing in water level. The whole area being the whole watershed. If there are repeated significant downstream flooding, then we can end up with the production of natural levees on opposite sides of the stream. So over time, as water levels keep increasing and then decreasing and fluctuating over the level of the banks, then what's happening is that it's picking up and moving sediment while it's doing this, and as it falls down the abrupt slopes of the sides of the stream, it's dumping that sediment out on the edges, and eventually with a repeated number of downstream floods will build up these sort of small hills or blocks on the edges of the stream or river, which can serve as natural levees. Which then means the water level has to be that much higher to qualify as a flood and spill over the banks. Flash flooding occurs when we have a pretty flat area where there isn't a direct downstream or down gradient area for the water to directly flow to, but instead it spreads out pretty well aerially. This can happen in flat plains, like is pictured here, or here, where there's not a whole lot of area or a thin area for it to go. It spreads out aerially. Other places where this can happen is in industrialized area or urban areas where we've made it flat for our convenience. And then that's why we get these flash flood warnings, and particularly in areas like Houston or Louisiana and these areas that are prone to flash flooding because, number one, they're below sea level, they get a lot of hurricanes, they get a lot of rainfall, severe storm events that are increasing with climate change. Destruction of infrastructure, and then flat lands because there wasn't a whole lot of change in the topography to begin with, but what there has been bulldozed over and built upon. And this isn't usually a huge deal in Michigan. Not that we have overarching mountains, but we've got plenty of hills here. What's much more common for us, of course, are lakes, which really are kind of the same idea as rivers and streams. It's just a low-lying point where water can accumulate, but instead of it flowing somewhere, it's flat in this low point with high points completely surrounding it. And it doesn't have to be super high, it just has to be higher than that accumulation point. And generally the lakes get deeper towards the center, of course. And these are not only points of accumulation for precipitation, but points of infiltration into the groundwater. So just like those rivers and streams, the lakes are also a point where we're seeing the water table surface. One side effect of excessive runoff is eutrophication. This is where we have excessive nutrients in the water and decreased oxygen levels. And while increased nutrients might sound like a good thing, it can mean too much algae, which means not enough light getting through the surface of the water, which means not good for the animals and other plant life below. And decreased oxygen levels, same thing, not great for animals in the water. And this is because excessive runoff all that runoff is going to pick up waste, and waste in terms of vegetation, plants, soils, other waste. It's going to dirty up the water, and it can introduce a lot of algae, which can reproduce and perpetuate this cycle. And so that increased algae on top of the lake reduces the amount of sunlight that's going through to the bottom, which means that less oxygen is being produced by those aquatic plants. And then you also have animals who are consuming oxygen and adding waste product to the water, meaning it's becoming more clouded and letting less sunlight through. And then as both animals and plants die, their decay process that occurs after death also consumes dissolved oxygen in the water, and then overall you end up with this decreased and continually decreasing amount of dissolved oxygen, and the amount of dissolved oxygen directly correlates to the ability of that body of water to support life. And for those of you who like to fish, you already know generally the clearer the water, the happier the fish. And that's on the more natural side of the process. Eutrophication can also be a result of other things being pulled from runoff, like fertilizers and other things that can be toxic to fish and other aquatic life, and reduce the clarity of the water, then reduce the sunlight passing through, and further, again, perpetuate that cycle. And these can be non-point sources, like what we learned about in part 1. It can be from a bunch of different places all going into one. While all these things individually serve as point sources, collectively it's the nutrient enrichment on whole, which is not necessarily a good thing, which may be counterintuitive, is non-point source. So we can have discharge of untreated municipal waste, we can have discharge of treated municipal sewage that's only partially treated, because they can't treat for everything. Discharge of detergents from launders, so primarily phosphates is the main concern there. We can get nitrates and phosphates from natural runoff, and more nitrates and phosphates from fertilizer, and then anything and everything from a bunch of parking lots. And then stuff from construction as well, mining, heavy metals, and cultivation, and other construction purposes. Wetlands are another type of surface water body. This is actually fairly common in Michigan. A wetland is an area of land that is covered with water for the majority of the year. These are our bogs, our marshes, and our swamps. You may have heard some campaigning or people advocating for protecting our wetlands, and that's because they house very certain types of soils and support specific plant species that are important for diversification and sustainability of life and ecosystems on whole. Now, you guys know what ponds are, but marshes are a wider area of lands, usually near a larger surface water body like a lake or a river or even tidal waters. It's an area that's relatively prone to flooding because it's flat and near a low-lying point. And the water level can change pretty drastically, but it's usually pretty saturated, and most always or most of the year has at least a little bit of water in it above its saturated point. And a swamp is almost the same thing as a marsh, except it's wooded. You have more trees, shrubs, herbs, mosses. It can support more plant life, and it can support more terrestrial plant life. A peat bog is something a little different. This is a low-lying area that has really poor drainage, meaning that the water is not going to move elsewhere into streams or rivers, and it's also not going to infiltrate, at least not very much, into the groundwater. And this makes a really happy environment for moss, and so eventually the moss will die, the layers of moss will die, and the new layers of moss will grow, and those will die, and it'll build up layer after layer, and as that decomposes, it begins to form a material called peat. And there are two types of peat bogs. There's bogs and then there's fens. The main difference in those is primarily being the acidity level. Bogs tend to be much more acidic than fens, and that's due to having larger quantities of plants that make the environment more acidic, such as sphagnum moss. And fun fact, sphagnum moss is a very effective natural water filter, so if you're really in a pinch out in the woods, you can squeeze the water out of sphagnum moss and it's totally safe to drink. Depending you don't have any man-made chemicals like PFAS or PCBs or TCEs in there. It probably comes as no shock that pretty much all of Florida is considered wetland. And, the Florida Keys, this is known for its wetlands across the nation. But for the U.S. on whole, there's really not that much wetland. Most all of our wetlands are along the southern coastal shore and up the eastern. And then pretty much everything else, there's a little bit scattered here and there, but there's not that much to go off of, and it's a really critical ecosystem. Michigan, it happens to have a good deal, as well as Wisconsin and Minnesota. And not only are wetlands critical environments or ecosystems, but they also can improve water quality. These can intercept runoff and then sometimes prevent contamination from moving any further. They can also help control erosion because it's a large flat area with a low level of water, so that helps to trap some sediment and have a bit of control on erosion. It's a good habitat enhancement for other habitats near it or ecosystems near it that rely on being adjacent to wetlands. And a lot of people enjoy them for recreation, especially here in Michigan. And also, of course, in places like the Florida Keys. Okay, so that's it for part 2 of the lecture on surface water. As usual, just a few reminders for you guys. Don't forget that you have a new assignment this week, Your Water in View. Checking out the water quality there that we went over in part 1 of the lecture. Don't forget to take the lecture quiz as always. Also, we're getting very close to the end of the semester here, so go take a look at your grades and make sure everything's looking right on your end. And then the study guide is coming up this week, so take a look over that. And then the final exam review session will be taking place during lab next week. While that's not mandatory, you can earn extra credit for it, and I would strongly encourage that you attend. It'll help you do well on the final exam. As always, if you guys have any questions, let me know. And feel free to reach out to me on Canvas or via email. Have a good rest of your week.